Hello, everyone. Okay, 1, 2, 1, 2. Hi. Hello, everyone. My name is Madalina, and today I'll speak about psychology of user experience in decentralized exchanges. This might be interesting for people who are concerned with greater user adoption and greater user retention in DeFi, but this will going to be a different take. We won't be talking about accessibility, but more about usability and cognitive biases and mental heuristics that can be applied in decentralized exchanges. I would like to introduce myself. My background is in computer science, but I specialize in human-computer interaction. I have worked as a software engineer on trading and portfolio management applications, but in traditional finance with BlackRock, mostly working on commercial UX and UIs for institutions. And then I have shifted towards a more decentralized scope. Since last year, I started contributing to a decentralized application, which is a trading console. All the code is open source. This dApp runs on the Vega blockchain, which is a blockchain built specifically for derivatives, which also allows for permissionless market creation. Okay, so I would like to start this presentation with a question that, in my experience, it has driven everything that I have worked on so far, which is, what do people want from a trading UI? And based on the experience of implementing user feedback, the answer would be everything. Yes, a person trading just wants a UI that is intuitive, user-friendly, and efficient. Well, they want speed and responsiveness to make quick decisions, to take advantage of market opportunities, but also it needs to slow them down to safely complete all the confirmation steps. They need to have all the data at their fingertips, and they need it now, but they would not be interested in everything, so it shouldn't overload them with too much information. For more complex exchanges, it needs to be customizable. If a user feels efficient with their own layouts, they should be able to create them. But there shouldn't be an empty canvas. They can experience a customization overload. How do they learn how to use the exchange if it does not have an appealing layout by default? And last but not least, they need to trust the process, and it needs to be secure. But what if something goes wrong? What if they do a mistake? Where can they get some help and support? Well, that is true for exchanges in general, regarding if they are centralized or not. But today, we will be talking about decentralized exchanges and about the psychology of design behind it and the cognitive biases and principles that may affect an exchange user experience. Before continuing, I need to make sure I'm making a very clear disclaimer. So this presentation needs to be visual to make sense. So what I plan to do is an easy to digest case study on multiple decentralized exchanges that are out there, some used for swaps and some used for derivatives. But there is no intention to do any type of critique or advertising. A very simple way for me to start talking about this would be to bring up a classic, which is the cognitive load theory. This is the theory which states that people have a limited amount of mental resources available for processing the information. So a platform can be designed in a way that minimizes distractions or reduces complex features. However, things are never that simple. This actually contradicts Tesla's law, which reminds us that if you simplify too much, you may end up just transferring some complexity to the user. And now let's get a little bit technical because we're trying to design something that is a bit specific. Let's talk about some key factors that can impact the trading experience and the cost of transaction processing indexes. The first one is liquidity. Users may experience wider bid-ask spreads and slippage when trading if there is lower liquidity. That is why DEXs implement different liquidity mechanisms which allow users to provide liquidity to the platform and earn fees in exchange, meaning that it impacts the fee structure on DEXs, same as the order books or any other types of models such as AMMs that have an impact on the pricing and the execution of trades as well. Implicitly, they impact the user experience. And now, however, you may say DEXs offer a higher level of security, as users now have full control over their private keys, assets are not held in a centralized location, but users are now responsible for managing their own security. They may be at risk of losing their assets if they do a mistake. Now, keeping those four important factors in mind, how do we design for this? Okay. To do that, let's try to simplify and break down the user journey in a decentralized exchange. Because any user interacting with a DEX will filter and gather the information to connect their wallet and start trading. and then seek the meaning of what's in front of them so that they can start trading safely or provide liquidity. And then they need to act within a given time in order to minimize slippage, assess, make the most profitable orders, generally follow their own trading strategy. And then they need to store bits of this interaction in their memory related to managing their funds or related to the realized profit and loss. So to improve their user experience, we need to understand the biases and heuristics that influence this decision cycle steps. Now, let's dive in. We're going to start with some laws that are repeatedly applied in popular DEXs for these aforementioned 4 categories. Category number 1, information. Users filter out a lot of the information that they receive, even when it could be important. And I'm going to start with the most popular UX law, which is super simple to understand and practice. If the number of choices increases, then the time to make a decision increases as well. And a very nice example of this law are lists. Now, to apply this law to DEXs, designers simplify the UI in order to minimize the number of clicks required to select a token to swap. And here you have some popular example of DEXs, Uniswap, Curve, and Balancer methods to select a token. So you do have a scrollable model to find a token. Designers made it even easier by allowing users to narrow down that list with a search filter. But these UIs from this slide, they do look very similar, right? Why is that? Well, that is because users transfer expectations they have built around one familiar product to another one that appears similar, and that is called the Jacob's law. Now, I'm staying on the same law here. In this GIF, we have examples of more than 9 popular swapping DEXs, and you can see how they are following very similar patterns for the swapping UIs. Designers, they end up leveraging existing mental models on exchanges so that users can actually focus on their tasks rather than on learning new processes. And this is very common, and you can see this being applied in general on any sort of trading UIs. So apart from limiting the user's need to learn new models, designers are also breaking down complex information, and they are disclosing it sequentially at the moment the users need it most. And this leads us to a design pattern that sequences information and actions across several views, which is called progressive disclosure. The purpose is to lower the chances that users will feel overwhelmed by what they encounter. So by disclosing information progressively, interaction designers reveal only the essentials, and they help users manage the complexity of what they see. Now, in this example, the user finds out information regarding the price impact and fees, and then about the route used for optimization, but only by interacting with the UI. In this case, it's important to know that designers need to choose very well what to disclose first and in what order. Why? Because people rely too heavily on the first piece of information they receive when they're making decisions. And that is called the anchoring bias. In DEXs, a platform can be designed in a way that discloses everything in a perfect sequence for the trading process. However, one thing that would give the users the motivation to look for more would be the confirmation bias, as people are more likely to believe information that confirms their existing beliefs or expectations. And if they don't find it, they might look for it, especially on trading platforms, when users have certain expectations, for example, regarding cost breakdowns. In DEXs, this law can be applied by designing the platform in a way that enables users to double-check or that reinforces traders' confidence in their trades. You may say by providing clear and accurate market data or offering risk management tools. And this leads us to help the users find the meaning. Users need to seek the meaning of what's in front of them, to analyze market data so that they can start trading safely, manage risk, and if they want to, provide liquidity. And I'll start talking about processing the information. When people are presented with complex shapes or a set of ambiguous elements, their brains choose to interpret them in the easiest manner possible. This law can be applied by designing the platform in a way that presents information and data in a very clear and concise manner, making it easier for users to understand and process the information. Now, here on this slide, we have an example of the creation of a new balancer liquidity pool. The UI needs to help the user's cognitive load and working memory because the human brain can only hold a limited amount of information at once. But how much? Well, it could be limited. It could be around 7 plus minus 2 chunks of information. Look, this is an older UI of Uniswap, but it exemplifies very well this concept where it was breaking down complex information such as liquidity pool details into smaller, more manageable chunks that are easier for users to understand and process. And of course, the user needs to pay attention to these details, maybe remember these details in order to manage the risk of impermanent loss. Now I'm going to move to another concept that also falls in the meaning category, and it is also related to managing the risk of your own portfolio, which is called the scarcity principle. In DEXs, this law is applied by creating a sense of urgency or scarcity around certain trades or certain assets. For example, in Vega's trading console, the UI highlights the fact that you're running out of collateral, coloring the amount in red or orange if you may soon not be able to cover the margin on positions. Having that knowledge, you can act in time in order to manage effectively your collateral. You can either adjust your positions or deposit more. And this leads me to acting in time, which is so important. Users need to act within a given time in order to trade effectively and avoid losses. There is this bias, which states that people are more strongly motivated by the fear of loss than the prospect of gain. And this is called loss aversion. Interaction designers are looking at implementing different tools for risk management and loss prevention, such as by providing clear and accurate, clear warnings when traders are at risk of making a loss, or allowing them to adjust parameters for their orders. On this slide, I have chosen a very simple swap example, where a user could adjust the slippage and they are getting a warning that a transaction can be front-run. What is interesting is that users tend to remember their interaction with the UI and store it in their memory, which leads me to the fourth category, which is memory. Users store bits of the interaction in their memory. They would usually remember the interaction related to their realized profit and loss or related to managing their own funds. And this leads me to an interesting design effect, which leaves a footprint. There is this effect commonly applied in multiple UIs, which is called the Zeigarnik effect. People remember unfinished or interrupted tasks better than completed tasks. And to apply this law to DEXs, designers can use visual cues such as progress bars or status indicators to show users the status of their trades and keep them engaged until the transaction is complete. And here you have an example of submitting an order on the Vega blockchain. And here, staying on the same rule, you have an example of awaiting confirmation on making deposits while bridging with Ethereum. With this law right here, I'm finishing the section where I'm presenting some biases, but also some visual and interaction design laws that I have seen being repeatedly applied in DEXs. And now I would like to highlight some features that would make you realize you're on a DEX. And this is how we're doing it on the Vega console dApp, but that could be applied to other DEXs as well. First, managing multiple keys. You may be able to trade on many keys, manage multiple accounts, and only you would be managing all of them. So don't forget, if all the keys are yours, then all the funds are just yours. So it is safe only if you keep them safe. Now, secondly, trying to make you realize you're on a transparent, decentralized exchange. Viewing as any public key. Remember, as a DEX user, you're on a blockchain, everything is transparent. You just need to know someone's public key and all the information is out there for you to check. This transparency feature on the blockchain is really interesting in a completely permissionless world because it is something that promotes transparency and accountability and fairness in the trading process. And since everything is visible on the chain, then the UI could actually help you visualize that too. Now, to conclude, there are lots of concepts that are out there that we could cover in this talk, but I would like to highlight the impact of the concepts described today and what they represent. At the end of the day, we want to give users an accessible way to use the valuable features of decentralization while trading. So we want to find both usability and usefulness in DeFi, and we can improve usability by understanding the biases and heuristics that influence these decision cycle processes, which are allowing users to filter the information, seek the meaning, act in time, and remember bits of the interaction. And I believe that by taking all of these in consideration and by using them in a correct and ethical way with empathy, we can lead to increased user adoption, retention, and satisfaction in DeFi. With this, I would like to thank you for listening to me. There is a QR code with the slides and with the sources attached if you'd like to dive deep into these concepts. Feel free to contact me anytime, ask me any questions. I'll be around for the rest of the conference and more than happy to discuss anything related to DEXs and psychology of user experience. Thank you very much.